Okay, we're still working on 6.1.5, the exercises in 6.1. And this is number 4, and we're supposed to find the arc length of this. And the arc length is, and we're supposed to do it from 2 to 5. The arc length is the square root of 1 plus this guy's derivative. So this is 2x to the 3 halves. The square root is the half, and that's the power of 3. So its derivative, we take the 3 halves down times this, and so that becomes 3x, and lower this by 1 to the 1 half. So it's the 3 square root of x squared dx. And that turns into integral from 2 to 5 of square root of 1 plus 9. The 3 squared is 9, and square root is x dx. This one's not too bad to do because of that square root comes out kind of nice. We can do a u sub for 1 plus 9x du equals 9dx. So this becomes the antiderivative. We're changing it here, so I'm going to change my limits. My u would now be, when I put 5, and 5 times 9 is 45, 46. And 2 times 9 is 18 plus 1, 19 of the square root of u, because u is all the inside here, square root of u, and du is going to be over 9. So I get 1/9. The antiderivative of the square root of u is 1 over 2 square root of u, evaluated from 19 to 46. So that's 1/18. 18 square root of 46 minus 1 over 18 square root of 19. And that's the exact value. We could have also done this with the calculator. Let's see what that number is. Make sure I didn't make any mistakes. So that's 1/18 parenthesis 1 over the square root of 46, 1 divided by the square root of 46 minus 1 divided by the square root of 19. Oop. That comes out to be an arc length of not very much here, 0.00455, and that is not correct. So what did I do wrong here? The arc length of this, so we've got to take the derivative of that. So this, we take the 3 halves down, so that makes it 3, and x to the 1 half, so that's the square root, and that's the derivative squared, which is 9x. U equals 1 plus 9x, which is 9 dx is du. So that goes there, that. And the integral of u to the 1 half, you add 1. Oh, that's what I didn't integrate right here. Messed up this last part here. Okay. To the 1 half, I have to add 1, so it's 3 halves, so it's 2/3. We have 1/9 times 2/3 x to the u to the 3 halves. So we have to do, that's 2 27ths times 46 to the 3 halves minus 19 to the 3 halves. Okay, let's do this again. Clear that. 2 divided by 27, parenthesis, 46 to the 3 divided by 2, minus 19 to the 3 divided by 2. Oop. Parenthesis. And that is the correct answer, 16.975. Now we could have also just typed that into y equals, clear square root of 1 plus parenthesis 3 square root of x, close parenthesis, squared, and graph that and calculate the area under that from 2, enter, 5, enter, and it says 16.975. Okay. 5. Find the definite region between these two graphs. And these are several separate problems. I'm going to do these on separate pieces of paper here. So the first one, let's make a sketch. And so this is an x equal y something. So this is a sideways parabola. It's facing to the positive, opening to the positive, and it goes through 0 and 2 on the y, 0 and 1, 2, facing positive. So that's the first one. The second one goes through 1 and 3, 1 and 3, and facing negative. And it's find the area of the region between. So we have to find out where they intersect in terms of y. And they're both x equals, so I set y times y minus 2 equal to negative of y minus 1 times y minus 3. This is y squared minus 2y equals negative y squared, the negative of minus 4y, which is plus 4y, and we get plus 3 times the negative, so it's negative 3. Add y squared to both sides, I get 2y squared. Subtract 4y from both sides, negative 6y. Add 3 to both sides, plus 3 equals 0. Nothing pulls out. I'm not sure that even factors. Let's see, 2, 6, and 1, 2, and 3. Nope. So I'm going to do the quadratic formula. So it's going to be the opposite of b, plus or minus b squared, minus 4 times a times c. 6 times 4 is 24 all over 2a. And so I have 6 plus or minus the square root of 12. Square root of 12 has a 4 and a 3, so that's 2 square roots of 3 over 4. I can factor a 2 out of the denominator and reduce this to 3 plus or minus the square root of 3 over 2. So to find this area, I'm going to go the antiderivative of this one is more to the positive. That's the second one. So I'm going to go, the second one was minus y squared plus 4y minus 3 minus this one, which was the y squared minus 2y dy, evaluating it from 3 minus the square root of 3 over 2 to 3 plus the square root of 3 over 2. And we can do some algebra here. So we got minus 2y squared plus 4y plus 2y plus 6y, and minus 3 that we have to integrate to find the antiderivative, which should be minus 2/3 y to the third plus 3y squared minus 3y, evaluated from that to that, which is ugly. So I'm going to go, I could go exact value, but I'm just going to go decimal value here. I'm going to go type in that equation. Minus 2 divided by 3, x to the third plus 3x squared minus 3x. Go to my table, and I want to go from the upper one, which is 3, okay, parenthesis, 3 plus the square root of 3, close parenthesis, get out of the square root, delete that parenthesis, go out of the square root, parenthesis divided by 2, and then I have to go from, on this one, parenthesis, 3 minus the square root of 3, get out of the parenthesis, out of the square root, close parenthesis, divided by 2, enter, and the difference of those two is what I want. And since they're equal and opposite, I'm going to get double that. 0.866 doubled. So I can quit. 0.866 times 2 is 1.732. That's the decimal value. If I plug these in and did the algebra on this, this looks like about the square root of 3. Let's see what it is. What is the square root of 3? Yep. So if I plug that in and then that in and subtract those two, I should get the square root of 3. Messy problem. Okay, that was 5A. 5B says find the area between, rotate the paper here, between the sine and cosine, sine and cosine, from pi over 4 and there's pi over 2 and 3/4, and there's pi, and 3 pi over 4 is here. So during that whole time, the sine is higher than the cosine, so I'm integrating the sine of x minus the cosine of x on the interval pi over 4 to 3 pi over 4 dx, and I can just type that into my calculator, graph it, and do it. Or I can integrate this. The antiderivative of sine is negative cosine, and the antiderivative of cosine is sine. evaluated from pi over 4 to 3 pi over 4. 3 pi over 4 on the unit circle is here. The cosine is negative square root of 2 over the 2. That's negative square root of 2 over 2. And the sine is positive. So we get the negative of negative is positive square root of 2 over 2 minus the sine is positive, so that's square root of 2 over 2 minus pi over 4. They're both the same, so I'm going to get square root of 2 over 2 minus and minus square root of square root of 2 over 2, which turns out to be, these cancel, and so I get minus, and that turns out to be square root of 2. And we could check that again with the calculator, but that should be it. All right. Next one, between these two. So this factors and that factors to y minus 2 y plus 1. So we have a sideways parabola going through minus 1 and plus 2, and this is positive, so it's going towards the positive direction. And then the other one is y equals 2x minus 1, which is goes through minus 1 with a slope of 2. Something like that. Looks like they're going to intersect there not far over. Wonder what that intersection is. To find that, solve for x here and substitute. So I'll add 1 and divide by 2, so x equals y plus 1 over 2. So y plus 1 over 2 would have to equal y squared minus y minus 2. So if I multiply this part by 2, I get y plus 1 equals 2y squared minus 2y minus 4. Subtract a y, so I get 2y squared minus 3y, and subtract 1, minus 5. And does that factor? So 2y, y, if I put 5 here and 1 here, I get 2y and 5y. If that's minus 5y and plus 2y, I get minus 3y. So this y has to be, add 5, divide by 2, 2.5, and y equals negative 1. So there's the negative 1, which we knew, and here is 2.5. So we're going to integrate, doing slices sideways, so the slices are dy, and this is the top curve, which is the line, and solving for y, it's y plus 1 over 2 minus the other one, which is y squared minus y minus 2, integrated from negative 1 to 2.5. And to make life easy on myself and get a decimal approximation, I'm going to go clear and type in y plus 1, x plus 1 divided by 2 minus x squared plus x plus 2, distributing that minus. Second, calculate the area from -1 to, from -1 to 2.5, and that area is 7.1458. Okay? Now I could have worked out the exact one, but I decided not to. Okay, now let's do D, a more complicated one. Okay, so D says find the area between y equals mx and this parabola. So the parabola looks like down 1 x squared, so it goes through 1 and minus 1 on the there. It goes through 0, -1 on the y-axis here, and mx, so that's just a slope line with a slope m. Now we normally try to find out where they intersect, so we say mx equals x squared minus 1, setting these two equal. Subtract mx and we get 0 equals x squared minus mx minus 1. And since we don't know m, we can't factor, so we use the quadratic formula. And so we're going to get the intersections to be the opposite of b, plus or minus the square root of b squared, minus 4 times 1 times minus 1 is plus 4, all over 2a. So they intersect at m minus the square root of m squared plus 4 over 2, and at m plus the square root of m squared plus 4 all over 2. And so we do the antiderivative of the line is higher, so we do mx minus the parabola, which is x squared minus 1 in parentheses dx, because we're doing vertical slices, so the widths are dx, and we're going from there to there. So when we integrate this, we get m over 2 x squared minus 1/3 x to the third, and that's plus 1, so plus 1x, evaluated from this one to this one. So I got to put that into the x's, which is a long mess, and then that into the x's, and subtract the quantity I get from there. And if you look at the answer book, in the answer you can see that it's really long, and they didn't do any simplification. They just left it all that junk. Okay? That's number 5. Number 6. So number 6, we're going to have, they say it's unknown region, and so we've got, first of all, this one. And so this is just a regular parabola, down 1, or up 1, upside down, so it's going to go through -1 on the x-axis and plus 1 on the x-axis and 1 on the y-axis. And then we have ax squared minus a, which, and a is an unknown positive number, so if we factored it out, it'd be x squared minus 1, only now it's times a. So it's still going to go through -1 and plus 1, but it's going to be right side up. And they ask you for what values of a will this area be 2? Or I could change that to, since this is very symmetric, when is this area 1? Well, let's take a look at the area under this curve, which we know. It's the 1 minus x squared from 0 to 1 of 1 minus x squared dx. And that area will be x minus 1/3 x to the third evaluated from 0 to 1. And if I put 1 in there, I get x minus 1, or I get 1 minus 1/3. Put 0 and I get minus nothing, so this is 2/3. This area above the x-axis and in here is 2/3. And this has to be 3/3 or 1, and this would be another one to make the total area 2. So I need to have the integral from 0 to 1 of a times x squared minus 1 dx to be 1/3. And you can see that this, if I pull out the a, just looks just like this one, only this has got a negative. It's the negative of it. So I'm guessing that a needs to be, this gave me 2/3 and this needs to be 1/3, a has to be 1/2. Now you can go through the algebra on it, but that's the reasoning that a has to be 1/2, because this has to be half of 2/3 or 1/3. That and that look very similar, just opposite in sign. And we want it to be opposite because this is a negative area, so I just pull it, I forget that that's there, and I go to 1 minus x squared to make it positive, turn it upside down from this to this, and I need half as much area, so I multiply by half to get 1/3, and that will do it. So a has to be 1/2. And 7. So on 7, we have f of x is 2 minus x squared. I'm going to draw this kind of big because I need to show you some details on this. So this goes through plus 2, and upside down parabola, so it's going to go through 1, and 1 down and 1 down there. And it says, find the average value of this. And they remind you of what it is right there. And we're doing this. This happens to be, if you put in, set this equal to 0, you're going to get x squared equals 2, and so x equals the square root of 2. So this is square root of 2. This is 1. And so we want the average value, which means we want to, we're from 0 to square root of 2. So we want to take this curve and pretend like it's water and put it in a tank and level it off. So we want to get it so this area fills this area and find that height. And what they're doing on this problem is trying to verify that that area is this area. So if we're going to do that, we have to find all this area, which is the integral from 0 to the square root of 2 of 2 minus x squared dx, and then divide by the width. So from 0 to square root of 2 is square root of 2. Divide by the width, and that gives me the height of a rectangle that will have the same area. So let's find the area. So that's 2x minus 1/3 x cubed, evaluated from 0 to square root of 2. So if I put the square root of 2 in there, I get 2 square root of 2 minus 1/3. square root of 2 times square root of 2 times square root of 2, which is 2 square roots of 2. So I've got 2 square roots of 2 minus 2/3 of a square root of 2, which is 4/3 square root of 2. That's all this area. And if I divide it by the square root of 2, I find that the height has to be 4/3. That's the height that it would pack down to and push this over into here. That's the average value. Now, to verify that, they're going to have us, so they said find out the sketch R, so there's R, y equals R, 4/3. And then we sketched it, we found the intersection. Now, well, we haven't found the intersection here, so we have to find out when this is 4/3. So we got 2 minus x squared equals 4/3. So I'll add x squared, I'll subtract 4/3, which leaves 2/3. And so I take the square root, and I get the square root of 2/3 is x plus or minus. But we only need the plus one. That's where they intersect at square root of 2/3. So now they want us to find this area. And then they want us to find that area. And they want us to show them that they are equal. So I'm going to go to my calculator. I'm going to clear. And the upside down parabola is 2 minus x squared. And then we have minus the lower one, which is 4/3. 4 divided by 3. And I'm going to go second, calculate the area from 0 to square root of 3/2. From 0, enter to square root of 2 divided by 3. And that area is 0.3628874. Now we're going to find the area here, which is all of this. I'm going to just insert a negative, a negative parenthesis, and then go to the end. That's going to switch which one's on top. That's going to make the 4/3 positive and this negative, so it's going to switch their roles. And now I'm going to find the area. Notice it flipped it over from square root of 2/3 to square root of 2. Second, calculate 7 from square root of 2 divided by 3, enter, to the square root of 2, enter, and that area is 0.3628874. So this area and this area are equal. And so this being pushed into there verifies that that is the average value. That's what they wanted us to show.